Hello everyone, greetings to you all. I would like us today to look at transposition of formulae, or what is also called subject of the formula. Times we are given a formula to transpose. Now making a variable a subject means isolating that variable and sending all the other terms on one side. So we have here the first one, make arrow the subject here. If I'm to make arrow the subject, I ask myself which operation is linking I and R. You see that the operation linking I and R is multiplication, and the inverse operation of multiplication is division. So if I'm to make arrow the subject here, it means I'll divide here by I and I'll divide here by I. So when I do that, I do on both sides. I will cancel here. We now have R is equal to V over I. I've made R the subject. Now if here you are asked to make M the subject, if I'm to make M the subject, I ask myself which operation is linking M and V. You see that the operation linking M and V is division. What is the inverse operation of division? Multiplication. So I have here multiply both sides by V. Take note. So V will cancel. It gives us M is equal to rho times V. I've made M the subject. Okay. Now we have this one. P is equal to 2 bracket L plus W. Here, when you have a situation with bracket involved, the very first thing to do is to remove that bracket. And if you are removing the bracket here, 2 times L, 2L, 2 times W, 2W. Okay. Now here we are making we have to make W the subject. Okay. We have here 2L plus 2W. Now we have to make the W the subject. So this one that is attached, what is separating both of them? Addition. So I'm to remove it, and to remove this term, either I subtract both sides. So I have here P minus 2L is equal to 2W. Okay, as this one comes this way, crosses the equality sign, becomes negative. And 2W, how do I make W the subject here? It's by dividing both sides by 2, the coefficient. Because the sign between 2 and W is 2W is multiplication. So when you divide that, you have your W. Your W is P minus 2L over 2. Okay, we'll continue with other examples here. Now, if you are given S is equal to UT plus half AT squared, to make A the subject here, we ask ourselves, okay, we have UT here, we have half AT squared this way. So we'll notice that UT that is here has nothing to do with A. So the first thing is we start by removing this UT. Either we cross multiply this way, or we take away. If you are to remove it, you subtract UT on both sides. I will subtract UT here, I will subtract UT here. So we're going to have S minus UT is equal to half AT squared. Now, having S minus UT is equal to half AT squared. The next thing is, if I'm to make A the subject, what are the operations linking A? Yes, we have here multiplication, half times A times T squared. Alright, so what do I do? The first thing, I have to remove this 2. To remove this 2, I multiply both sides by 2. This one has 2 terms, so I multiply by 2 here. We're going to have 2 s minus ut. When I multiply now, you give at squared. What do I do next to have a alone? What you ask yourself, which operation is linking a and t squared? The operation linking is multiplication, because at squared means a times t squared. Since the operation is multiplication, the inverse of multiplying is dividing. I divide both sides by t squared. So my a implies my a is 2 into s minus ut divided by t squared. You see that you have made a the subject, because all on the right now it has no a. Yes, we have the fifth example here to make y the subject. We have situations whereby we have the square root. The square root, to remove this square root, we start, since what we are making the subject is here, is inside and is under the square root. So the square root must be removed. And to remove the square root, what do? We square both sides. I square both sides, square there, square there. So, like the antibiotic here to remove the square root is simply squaring both sides. And the antibiotic of removing the square is looking for the square root. So when I square both sides, if I square, the square root will come out is ay plus b equal to c squared. Making y the subject here. After the operation, whenever we see square root and any other, and what we are looking for is below, we remove that square root. What next here is ay. Ay is equal to c squared minus b. So y will be c squared this will be c squared minus b divided by a. That's our y. C squared minus b divided by a. Okay, let's look at more examples here. Now we have square root of x plus c is equal to d. We are required to make x the subject here. Here we have to make r the subject, and here we have to make l the subject. Now the first thing is that when you have to make the subject and what is there is under the square root, you start by squaring both sides to remove. Take note that we are using, whenever we square it, it removes, because square root, for example, a to the power, the square root of a, right, is a to the power half. And from the law of indices, a to the power half, all that square, it will mean a to the power half times 2. Half times 2 is 1, so which is a to the power 1. Is that okay? So that's what it means by applying this the square root, that the square root removes everything. Like here, if I square both sides, it will just remove this square root. We don't remove it by wiping. Okay? If I square both sides, it will remove that square root. And we're going to have s plus c is equal to d squared. Take note that when it concerns transposition, what you do on the left, you must do on the right. So it gives us x equal to d squared minus c. And we are done. Now, likewise, if you make r the subject here, the first thing is how there's also this fraction. How do you remove this fraction? This fraction has nothing to do with multiply. We have 3a is square root of cr. And to have r is under the square root. Square both sides. We have 9a squared is equal to cr. How do I make r the subject now? I divide both sides by c. So r is 9a squared over c. 9a squared. Okay. That's it. Look at another example. Period is 2 pi square root of l over g. To make l the subject. Okay. This one, the 2 pi times square root. It means we can start by removing the multiplication. The opposite of multiplying is dividing. I divide here by 2 pi. I divide here by 2 pi. So we now have pi over t over 2 pi is equal to square root of L over G. How do I remove the square root? By squaring both sides. So when I square, this one now becomes t square over 4 pi square is equal to L over G. Now we have to make the L the subject, okay? But we have what? We have division. How do we remove that division? By multiplying both sides by G. Multiply here by G. So our L will be GT square over 4 pi square. GT square over 4 pi square. Yes, we have GT square divided by 4 pi square. That's our L. Okay, what if you equally have a situation here, like this case, that we should make U the subject? Okay, so the opposite of squaring, when you have a square, to remove it, you use the square root. So the first thing we're going to do here is that we have to make U square, but we still have 2as here. So we are left with, we say v square minus 2as equal to U square. How do I make U the subject? How do I remove a square? To remove a square, we'll simply be taking the square root of both sides. So I look for the square root here, and I look for the square root. Square root of U square means the number that what we multiply by itself that will give U, and it's U times U square that gives U. So it implies U is equal to square root of V square minus 2as. Alright, thank you. Thank you for watching. Thank you. Please like, share, subscribe. See you in the next video where we'll apply this concept in solving linear equations.